Hello. In this session, we will see types of beams. In the last session, you have seen types of supports. Okay, so now we will see the beams. The beams which is supported on the supports. So already you saw four types of supports, right? So types of beams. This session is mainly dependent on the last session topic, that is types of supports. Please do watch if you're having any doubts with the supports. Okay, types of beams. Okay, first one, simply supported beam. Okay, so you can see two sides you have a simple support. In the last session you have seen, no, like how the support will look like. Simple support, it is just rigidly connected with the beam. So you have two sides at a point A and a point B. You can see two supports, and in the same way you have a two vertical reactions. So what are the total reactions you have in this support? Two, right? One is RA and one is RB. You have two supports, two reactions in the simply supported beam. While doing the problems, if you have a simple support in the beam which you given for the problem to solve the problem, so we need to mark the reactions. Initially we need to mark the reactions, then we need to start the problem. Okay, so once you see the simple support, so you have to think simple support always having a one vertical reactions, each point A, point B, each you will be having totally two reactions. Next one, cantilever beam. So how the cantilever will look like? You can see you can just see it is used by fixed support, right? See this fixed support. So cantilever beam looks like one side fixed and one side free. So it will look like this. So the cantilever beam is anchored at only one end. The beam carries a load to the support where it is forced against by moment and a shear stress. Okay, for cantilever beam I'll give a simple example. You can see in front of the building, in a portico, you can see a slab over your portico for the parking the vehicles, just without parking also. So that is your cantilever beam. One side will be fixed, one side will be free. Or else you can see a swimming pool diving bar. You can see in a swimming pool, one side fixed, one side free. So that you can take an example for a cantilever beam, one side fixed and one side free. Now we will talk about the reactions in the cantilever beam, right? In the cantilever beam, as I told, only one support is there, one end it is free. So what happens in the fixed support? How many reactions we have? Three. One is horizontal, one is vertical, one is moment. At the another end it is a free end, so no reactions. Okay, so overall total reactions in the cantilever beam is 3, right? Next one, propped cantilever beam. Okay, how it will look? See, you can observe one side fixed, one side you have a roller support. So this type of support is this type of beam is called propped cantilever. And guys, I'm telling once again, this types of beams is mainly depend on the supports. So we are just placing different supports here, right? We have four types of supports. In that we are just placing all the supports near the beams. So in the propped cantilever you can see one side fixed support is there and the other side roller support is there, right? So this type of support is called propped cantilever. Okay, and one more thing, in propped cantilever, the beam should be one side fixed, another side it can be on the roller or a hinge or a simple support. It may be in on the any other support. Okay, but in this figure I have shown with the roller support, right? One side fixed, one side on the roller. Okay, so now just we will count how many reactions are there in the propped cantilever. Okay, you just count all the reactions. At A, as usual, three reactions, right? Horizontal, vertical, moment, three reactions. At the another end, you have roller support. Roller support, how many reactions? One, only one, right? So the total reactions in this beam overall is 4 reactions, right? So while writing the theory, you need to mention all the magnitude, that is the intensity of that reactions, that is RAH, RAV, M and RB. So you have 4 reactions in this beam. Next one, hinged beam. So you can see both the sides you have a hinge, right? At A and at B you have both the sides hinge beam. So total reactions in this beam is total you have a 4 reactions. At A, hinge is there, one is horizontal, one is vertical. At the B, again one more hinge, so that is also horizontal and vertical. So total reaction is 4 reactions you have. Next one, beam with one end hinged and other on the roller. You can see at A, you can see hinge is there. At B, you have roller is there. So just mark the reactions at A. So we already know at the hinge we have 2 reactions, and at the roller you have 1 vertical reaction. So the total reaction in this beam is 3, right? So one end hinged and one end on the roller. We'll move to the next beam, that is fixed beam. Okay, so in this beam you can see both the ends of the beam are rigidly connected, right? So here you can see a fixed beam means the more reactions at each side. One side you can see left side and also right side. Left side 3 reactions and right side 3 reactions. So totally you will be having 6 reactions in the fixed beam. Once left side 3 reactions and right side 3 reactions, because it's a fixed beam. And one more thing, once again, cantilever beam means one side fixed, one side free. So that will be cantilever. So this is the fixed beam, that is both sides rigidly connected. Okay, next one, overhanging beam. Okay, so how the overhanging beam will look like? You can see in the picture which is shown in the left side, and you can see the picture which is shown in the right side. So you have a different categories of overhanging beam. Overhanging beam is simply, very simply if I want to tell, after the support the beam is still extending. You can see, right? After the support still the beam is extended. The 2 supports will be there, still the beam will be extending after the support. So that will be your overhanging beam. The ends of the beam will be extend beyond the wall or the support. So overhanging of the beam is the unsupported portion of the beam. It may be one side or both the sides. Whatever I told, the beam is extending both sides or a single side. If it is extended single side or it is extending both the sides, both are we are calling as a overhanging beam. Very simple. It is the beam which is extending after the support. So that's it. So in the figure, guys, in the right side figure you can see supports are there, which I have marked A B A B A B, right? So you can see which type of support is this. Simple support. So simple support means definitely one vertical reaction. So at A, one reaction, at B, one reaction. So totally how many reactions in the overhanging beam? You have 2 reactions, 2 vertical reactions in the overhanging beam, that is RA and RB. Okay, next one, continuous beam. I think continuous beam is the largest beam, right? A continuous beam is a statically indeterminate beam. I'll just explain the next session what is statically indeterminate, right? The end span may be cantilever, may be freely supported or a fixed support. You can see a number of different supports in this beam, right? So here reactions will be more than 2, right? More than 3, more than it will be more compared to other beams. It will be the largest beam. Continuously you can see number of supports At A you can identify which is that hinge, at B you have roller, at C you have roller, at D you have roller. So you will be having more than one support, more than two supports. So that type of beams is called as a continuous beam. So thank you.